Welcome to Lecture 5. We are going to be looking at solving different types of equations, and as you can see there are a lot of them, and I've added one substitution at the end, but bear with me, this is review and hopefully you're familiar with doing these already. Let's begin with a simple reiteration of definitions so that we understand where we're at. An equation simply says two statements are equal, or two algebraic expressions rather are equal. The equation itself is the statement. To solve it is to find all values of x for which that equation is true. And we call those values solutions or roots or zeros depending on the different contexts, and we'll get into that more in future topics. Okay, now an equation can have one solution, many solutions. It can have an infinite number of solutions. For example, 2x plus 2 equals 2 times x plus 1. That equation is what we call an identity because it is true for all x. So if you wanted to say the solution set, it would be all real numbers. Okay? An equation can also have no solution, in which case the solution set is empty and we write it as the empty set. And here's an example of an equation that has no solution, and let's see why. We know that the absolute value of a has to be at least 0 for any number a. So the absolute value of x minus 1 has to be greater than or equal to 0 for any value within the absolute value bars, and so for any value x. Okay? And of course then this equation cannot be true for any value of x. Because whatever I put in for x, I'm going to get a quantity which is at least 0. And so there is no solution, which we would indicate as the empty set. Okay, now the most basic type of equation is a linear equation, which is an equation where the powers are raised, the variables are raised to the first power, and we just have one solution. And you're used to these. These are the first types of equations you learn to solve. And to solve that type of equation, we simply want to follow these basic steps, remove parentheses and simplify, then rewrite the equation by isolating the variable. Variables on one side, numbers on the other. Solve and check. Okay, so let's do this on this first example. Step 1, we simply multiply. And we get 21x plus 3. Okay? And then we combine those. Let's see, we'll get 6x minus 2 equals 21x plus 3. And then step 2 is to isolate the variable. Now, my personal preference is to keep the variable positive, so I'm going to subtract 6x from both sides. You see, that will keep my x term positive. And then I can subtract 3 from both sides, and that isolates my variable. Okay? So negative 5 equals 15x, which is the same thing as saying 15x equals negative 5. And if I solve that, I simply divide by 15, and I get x equals negative 5 over 15, which equals negative 1/3. So that's what we assume is our solution, but we want to check that. And to check that, we always want to go back to the original equation. You could have made a mistake in the very first step when you distributed the minus, for example, or distributed the 6 if you forgot to distribute it. So you always want to go back to the very first equation and see if when you plug in your value for x, do I get a true statement? So I have to plug it in into both sides and see if they're equivalent. Okay, so let's just do some basic fractions. 1 is 3/3, so that'll be negative 4/3. And we want to know, is that the same as 3 times negative 7/3 plus 3/3? Okay, so the 6 and 3's will cancel, leaving me with 2. So that's 2 times negative 4 plus 4. And the question is that the same as 3 times negative 4/3? So on this side I get what? Negative 8 plus 4, negative 4. Is that equal to 3 over 1 times negative 4/3? Yes. So our solution is correct. And so we have x equals negative 1/3. And so linear equations should have one solution. Okay, let's do another one. This time it has fractions, so it may not start out looking linear, although x is raised to the first power. That's the big clue. But let's see what happens. And we're used to clearing of fractions by multiplying through by the LCD. We did this with complex fractions. So the LCD of our denominators 2 and 4 is 4. Don't be tempted to use 8. That is a common denominator, but not the least one. Okay, so what I'm going to do then is multiply both sides by that least common denominator. And the key is that what you do to one side of the equation, you have to do to the other. So I multiply both sides by 4. And notice what happens here. I can multiply that out. And here the 4's just cancel, and I'm just left with x minus 6. Okay? And here I get a cancellation. So again, I can write that as a linear equation without any fractions. That's the whole idea of clearing of fractions, is to rewrite it in a simpler form. Okay? And then let's solve that equation. I'll subtract x from both sides, and I'll subtract 4 from both sides. Okay? And so I get x equals negative 10. Now I'm pretty confident there. I need to check to make sure that I've done that right. So I again go back to my original equation. Is negative 10 over 2 plus 1, is it equal to 1/4 times negative 10 minus 6? And I don't think it takes much to convince you of that. Negative 5 plus 1 equals 1/4 times negative 16. And that's the question. And yes, of course, they both equal negative 4. Okay?